I wanted to run my.
I already have it now. So, don't tell us. All right, let's see.
I tell you how every kid starts to cry like.
So tomorrow we start our chapter review, meaning today we are finishing chapter 7, okay? Let's go over these 4 problems. I did another, wow, that's really light. Another completion homework grade. I will write these answers down. Thank you, Jenny. 1.69. It's still not very dark. Okay, by the way, I changed my contacts.
Yay.
So much better.
3, 4.
Huh?
I really need to get it.
Okay, any questions on number 1? All right, we are putting it into log form, and you divide by log 13, and you just put it in the calculator. Okay, any questions?
I completely made a math error on the first problem.
Okay.
And like noticed it was a 13 rather than a 3.
All right, well, just make sure you check. All right, number 2. First step for number 2, we subtract 8 from both sides, and you're left with this. And then you put it in log form. And here's the exponent. 5k goes in the front. Divide by log 9 on both sides. That's gone. You're left with, here, I'm going this way. 5k equals, and I did this on my calculator. Log 42 divided by log 9, and then you get an irrational number, decimal, and then I divided by 5. If you are off, did anyone get something close to this but not exactly? Okay, that is okay. So it is approximately 0.34.
What if I put for number 3? What if I put 0.733?
That's fine, totally fine, yeah. So let me do little squigglies so you know. All right, number 2, check. Number 3, first step, divide by 2 on both sides. So this is gone. 18 divided by 2 is 9. And this is our new, easier problem. Okay, I hope you can see my arrows. You put it into log form. No, sorry, you bring the n over. Well, I kind of did it at the same step. N exponent goes in the front. Divide by log 20 on both sides. This is canceled. And 1-step calculator. Any questions on number 3? All right.
Number 4, I actually put 4. 9x minus 4. 9x minus 4
Oh,
plus 1.
yeah. Well, if you did the steps right, you should be good. Okay. Well, if you had 4 there, you won't get the same thing.
Yeah.
So number 4, just like number 3, you divide by 6 on both sides. Unfortunately, it does not work out perfectly. I left it 21 divided by 6. You could have also done a decimal. I think it's what, 3.5?
Yeah, 3.
Okay.
Mm-hmm.
I would, that's probably easier.
I got like 0.021.
It,
That's a 0.11.
negative 0.011. There you go, a little better. So here here's your exponent, 9x plus 1. That goes in the front because of the power rule. 9x minus 1, log 4 equals, divide by log 4. Let me scoot this up a little bit. What you do on one side, you do on the other. And you are left with, some of us may do this a little differently. Calculator, leave it in your calculator. I'm okay with what you decide to keep in your calculator as long as you get the same end result. Okay, I'd skip a step here if you see I left that in my calculator. This, I just kept it, okay? So I did log 3.5 divided by log 4, and you get your irrational number, minus, that's a mistake. That's not a decimal. That's a, let me write that a little neater. Subtract 1. Subtracting 1 here, you got to do it on the same side. And I put this in the calculator. I left it. Then I subtracted 1. Kept it in my calculator. Then I divided by what number? 9. And you get this.
I think I forgot about the 1.
Yeah. It's
Wait, but isn't it 9x minus 1?
See, that's what I did. Okay.
I got
No, the work is right. I wrote it down. Originally, I did it wrong. You see my erase marks everywhere. So you add 1. That's right. Okay. Let me check, make sure that is right, but I'm pretty sure. Because I did it wrong. I wrote it down wrong first. I don't mean to be rushing, but I'd like to get started. All right, so I am doing this. Log 3.5 divided by log 4. Can you see? No. There you go. Parentheses, enter. And then I add 1, right? No, it's plus. This is a plus.
Yeah, it's a plus.
It's a plus.
And so you,
Yep.
so like you subtract it instead.
Yeah, okay. There's that, minus 1 divided by 9. And there it is. So negative 0.011. I got 0.11, that's 7 rounds. Makes that 0 a 1. Grace, I did the same thing you did first.
Yeah.
That was yesterday. That was a long time ago. Okay, sorry about that. It was very faint, but there we go. When I say calculator here, I'm leaving all my work in the calculator. That way I'm not writing anything down. Okay, you can do it your way. Okay, but calculator here won't make a mistake. All you have to do is make sure you push in the right button. All right. Let's move on to growth and decay. Don't be alarmed with this, okay? I have done all the work here, and I'm going to make it very elementary. I think you're going to be pleasantly surprised, okay? I'm going to give you 2 formulas, well, 2.5, because one's growth and one's decay. So let's move on. I want to take good notes, because you'll see how
I don't think I did last one.
oh, you didn't?
I don't think so.
Okay. I got you.
Thank you. Word problems?
No.
It looked like when I first seen this paper, I'm thinking, doing proportions.
No. This is exponential growth and decay. So,
Proportions were so easy.
2 formulas. 2.5, actually. You'll see. Okay. The first one, I'm just going to give it to you, and then I'll explain what they mean. Yes, write this down. I would put it in your notebook. I would do it. Yes, I would definitely write this down. I would write this down, Davis.
I got a piece of paper.
Okay, so let me just tell you what these mean. Let me change colors just so you know where the difference is. I have lost my hot pink pen. It was really pretty. Put it in here. No. Okay. P equals initial amount. A equals final, meaning your answer, okay, it's pretty. Growth factor,
And
amount. There you go. Growth factor, I'll explain. So I'm gonna do dot, dot, dot. As I will X, dot, dot, dot. Okay. Let's look at number 1 on your paper. Okay. I'm going to tell you things and what these mean, and I want you to write them down because it literally what's going to be on your test is very similar. This is common sense. You're going to see a lot of it's common sense. Okay. So number 1, how much of a radioactive kind of, what's that, y'all? Molly, I don't even know. Anybody got it? Okay, I love that. Will be left after 132 hours if you start with 1,000 grams and the half-life is 66 hours. Okay, so number 1, we have our initial amount. What is our initial amount? Anybody want to take a stab at that? Amount.
136 hours.
1,000 grams.
Okay. I'm glad she said that. Amount, if you look at the other numbers, we have hours and hours. That's time. So the initial amount, the only option is what? 1,000 grams. Okay. Our A is our answer, so we don't know that yet, right? So now we need to focus on the growth factor and X. Okay. Please notice X is an exponent. Okay, does everybody see that? Okay, we're still dealing with exponential functions. Now the work comes in. This is where I'm gonna even write easy work. Okay. The key word here is half-life. Okay. Step number 1. 132 divided by what? What's the other number? 66. And if you do the math, it works out perfectly. Does anybody know that? 2. Half-lives past. Okay. So sorry, thank you. Yeah, keep telling me that because I need that over here too.
Okay.
And I'm zoomed in a little more than usual, so I'll make sure if you don't mind. All right, so here we are. Here's 2. Any questions? Okay. Now, the growth factor is given to us in the problem.
Is it 132? 16.
It's a half. You get it? Half-life. So if I said the opposite, double, what's the opposite of a half? Right, or if I'm doing exponentially, I'm going to say double. So you have an item and it has a half-life, okay, that's a half. Or you can also, instead of a half, it'll say the opposite, which is double. So if it was double, this wouldn't be a half, it would be 2. Okay, so the growth factor is we're dealing with half-life. So final step here, step 2. Here's our problem. I'm going to write the formula over here just so I can P times a half X. Okay. What's my X? We found it.
The X is 2.
X is 2. All right, I'm going to use my pencil, and I just want you, this 2 is that 2. And now you just plug it in your calculator. Order of operations, what do we do first? Right. You want me to show you how I put in my calculator? Okay, I do it all at once. 1,000 times 2 to the, nope, sorry, not 2. 1/2. Notice, what did I put around half? Parentheses, exponent 2. That's how I put it. Now, please understand, your calculator may be newer or older. Said that several times. And you push, and yeah, I made a mistake. Hold on. And you get 250. I had an extra exponent because I didn't. Order of operations, just to let you know, you take 1/2 and you square it. That's 1/4. 1/2 times 1/2 is 1/4. Then you say 1,000 times 1/4 and you get 250. So that's your answer. A equals 250. Going back to the original problem, does that make sense? How much of this, whatever that is, will be left after 132 hours if you start with 1,000 grams? Well, it's going to be less, right? Because we're doing half-lives, we're going down, okay? Yes.
Wait, so when you wrote growth factor equals and then you put the blank and then the X equals, so the X is 2, so the growth factor will be 5. Okay.
Thank you. So question 2 reads, a colony of 65 bacteria doubles, there's that growth factor. So what's our growth factor here? 2. And, I'm sorry, doubles in size every 409 hours. What will be the population? What will the population be 818 hours from now? Okay. Can I move this paper and do a new one? Going once, going twice. All right, number 2. Here's our formula. A equals P. What's our growth factor here? We're doubling, so the growth factor is 2. Yeah. Okay, so our first step is we need to do the math using our time. So we need to know how much does it double. So we got to say 818 divided by 409. And anybody got that? 2. So it doubles 2 times. Okay, so that 2 is our X. What is P? What is our initial amount?
65.
P is 65. So we have A equals 65, parentheses 2 to the second power.
I have a question.
Mm-hmm.
So when it's using the second power, is it always going to be the second power?
No, this is the growth factor. This is the doubles.
Okay.
This 2 comes from this 2. Watch, this is the same. I did the math. 818 divided by 409 is 2. That 2 is that 2.
Oh.
Okay. Growth factor is 2 because of the word doubles, okay? If it said half-life, what would this factor be? A half.
How do you tell if it's a half-life?
Read the problem.
If it says half-life.
It says half-life and then not like one says double.
Right. You see the word doubles? Okay? If you want, underline it. All right, so put that in the calculator, y'all. Let me know what you get.
I got 260.
Did anybody else get 260? Yep. And that's it. You're either going to have a word problem that says half-life, or it's going to say doubles, okay? Any questions? Yes, ma'am.
So if that would not say doubles, that 2 would be a half?
As long as it said half-life.
Yeah.
Yeah.
Okay.
Okay. So 1 and 2, same formula, different lives, if you will. Half-life or double. All right, I'm going to do a squiggly because we're going to the other formula. 3, 4, and 5 are easier for me. Okay? Here is your second formula-ish. We have exponential growth, which is y equals a times 1 plus r to the t. I'm going to scoot that up. And I will tell you what these mean. So A is equal to initial amount. One, yeah. R is rate in percentage. And T, what do y'all think T stands for?
Time.
Time, like length, hours, minutes, seconds, that kind of thing. We also have, what's the opposite of growth?
Decay.
Decay. There is one difference here. Y equals A, 1 minus R to the T. This is 3, 4, and 5. If you notice,
Okay, these are the notes for it.
yes, but I'm getting ready to do 3 with you.
Okay.
Yep. So under these notes, I'm going to do number 3. Number 3 reads, more and more people are purchasing food from farmers markets. As a consequence, a market researcher predicts that the number of farmers markets will increase. That's common sense, right? More people are shopping at them, the more markets they're going to be. They're increasing by 5%. Guys, percent as a decimal, what is your rate?
0.05.
0.05. There's your rate. If there are 7,290 farmers markets, how many will there be in 5 years? T is 5 years. And A is if there are initially 7,290. This is the original amount. And now you just plug it in. Okay, how do I know, is this growth or decay? Are we increasing our markets or decreasing? Increasing, so we are doing growth. Okay, key words here. So use your formula. And you just plug it in. A is 7,290. 1 plus 0.05 to the 5th power. And you just put all that in your calculator. Go ahead and do that now.
I got a decimal.
You will not get a decimal. Order of operations, do parentheses first. 1 plus 0.05, take this number to the fifth power, then multiply it times that. I'm sorry. You will get a decimal, but it's a large decimal, right?
Yeah.
You're going to round. Do we round up or down? Who says up?
Well,
Think of it this way, common sense. What'd you get, Katie?
55,058.437.
They might get something different. Did you get that? Did anybody else put it in here, in the calculator?
I
I
got,
did, I got that.
What did you get, Zach?
I got 7,291 and then a bunch of decimals.
Okay, well,
I got that then.
1 plus 1 equals to the fifth power times 7,290. Here is your answer.
That's what I got.
9,304.09, etc. Sorry, you cannot see that, the glare.
Really confused now.
Okay, guys, this is just put in the calculator. Okay,
I put it in the calculator.
ordered operations. Okay, you gotta make sure you're doing it right.
Yeah, and are you asking us to round our answers?
Okay, I'm getting ready to ask, guys, here's your answer. It's not a whole number. Can we have 0.092591 of a market?
No.
No, so you need to round down. Answer would be 9,304. Please make sure, add this together first. Take this to the fifth power, and then times it times that 7,290.
I got 55,350.
Okay, let's try it again. 1 plus 0.05.
I did that.
Did you take that to the fifth power?
Yes.
What'd you get?
7.59375.
1.05 to the fifth power is this.
Oh, when I did 1 plus 0.5, I got 1.5.
No, it's 1.05.
It's 1.
Okay,
I don't.
5% as a decimal. 0.05.
Oh, plus 1.
Plus 1.
Okay.
Yeah, make sure we can get it. I'm gonna put, it looks like this is okay if I leave it right there. Did you get it? And do y'all understand why we can't round up? Okay, you gotta round down. I'm not gonna worry about that.
Like when you're like rounding, like trying to find like the total amount of money, like in like and like a market, it's like you're like rounding to like the nearest like whole number.
Yes. Well, it's a market. You can't have half a market or a third of a market. Let's look at number 4. Okay, I'm gonna go back up here so I have more room. Charlie buys a car for, is that 23,100? Is that right? I've marked through it. His car immediately, are you listening or are you just drinking water?
Thirsty.
Okay. Starts depreciating. So we have growth or decay? Decay. Losing 20%. What's 20% as a decimal?
0.20.
There you go. Of its value every year. How much will the car be worth in 2 years? So what is our rate? There you go. What is our time?
2 years.
2 years. All right, and our initial price, 23,100. Okay. So our formula is decay because it's depreciating. So here we go. Y equals 23,100 1 minus 0.20, all to the second power squared. Okay, here is my calculator. If you want to watch me, or you can try it first. Order of operations, I do this first. 1 minus 0.20, you get 0.8. Raise that to what power? Second, and you get 0.64. All right, one more step. Times that by the original price, 23,100. And you get that. 14,784.
I get it now.
That to me is more common sense than anything, because you're thinking of something that really could be you guys. Because the second you drive a car off the lot, the value's down. Literally the second it's off the lot. Like a lot. Just letting you know. Think twice about buying a new car. All right, number 5. Do number 5 quickly by yourself. Is number 5 growth or decay?
Growth.
How'd you know that? What's the word you saw?
Increase.
Increases. Do it now.
When did I keep getting to that one?
Which one? You don't divide.
Divide.
You
Did I hit
multiply.
divide?
Yeah.
Oh.
And it's 23,100.
Oh.
And number 5, what is our initial amount?
67,000.
Yeah? What is our rate?
0.06.
Right, 6%, which is equal to 0.06. And what is our time? What's it going to be worth? 11 years. So now we just plug it in. It's kind of a weird exponent there. So we're dealing with money. So how much should we round? What place value should we stop at?
The nearest whole number.
Well, if we're dealing with money, we can do,
Like round down.
so I have 0.5 cents, approximately 127,465. Okay, so it's 12:30. What I want you to do, it's kind of weird, I haven't done this before. You have the same problems on the other side. Okay, I want you to do them again. Okay, do them again. Tomorrow I'll have the chapter review. We will focus on growth and decay first. We'll kind of work backwards. All right, it does not get any harder. So do these again, right next to it. Yes. All 5. Yep. Just do them again.